Hey, I'm Juan, and this is Eric.
Oh, hello.
And we went to Japan for 2 weeks. This video, though, while it will show some of the footage from that time, is mostly meant to be informative. So if you want to look at just the background footage of Japan, go right on ahead. I hope you enjoy it. If you want to listen to me babble, I'll be talking about a 2022 FRQ question. It's a particle problem, and it's pretty straightforward. Alright. So we're given this problem where a particle is moving along the xy plane. We're given some parametric functions, in this case dx dt and dy dt, and the particle's location when t is equal to 4. Cool. Part A asks us for the slope of the tangent line at t equals 4. So since slope is just the change in y over the change in x, in other words dy dx, we can actually find this using dy dt and dx dt by putting dy dt over dx dt and therefore cancelling out the dt bit. Therefore, we can get dy dx simply by plugging in to each one accordingly, t equals 4, and there we go, that's done. Part B asks us for the particle's speed and for the particle's acceleration vector at t equals 4 once more. So, since speed is not a vector quantity, we need to take the individual x and y velocities of the particle and add them together somehow. By somehow, I mean by using this equation. So by plugging this in and using t equals 4, we can get that speed for t equals 4. Finding the acceleration vector is going to take a little bit more work. So we have the velocity functions, but we need the acceleration functions, and therefore we need to take some derivatives. Luckily, since this is a calculator question, we can use my absolute favorite method for finding derivatives, calculator sub. We get the acceleration functions, which I've named ax of t and ay of t, and finding the acceleration vector for that point is as simple as plugging in the number, and we write it in vector form, like so, and just like that, we're done with part B. Part C is probably the trickiest part of this question. It wants us to find the y-coordinate of the particle when time is equal to 6. So from previous parts, we know the particle's position in the y direction at t equals 4, but we need it at t equals 6. So we need to add on the distance that the particle has traveled between the time of 4 and 6. We can use an integral to do this, since we're given the velocity function, and we should by now know that integrating velocity from one point to another gives the distance traveled between those 2 points in time. Therefore, we can add the y-coordinate value at t of 4, and the integral from 4 to 6 of dy dt, like so. And thankfully, we can use calculator sub to make our lives a little easier. This last question wants the total distance that the particle travels from t equals 4 to t equals 6. So, in this case, we aren't really finding location anymore. We want the length, the distance that this particle is going to cover between that and the time interval. So, in other words, we're looking for arc length here. So if we recall the equation for arc length that I just googled, we can see that all we have to do is plug our dy dt and dx dt equations into this one and set the bounds as what we need them to be. Calculator sub makes this extremely easy. Simply plug in and move on. Alright, that was it. Now, if you don't mind me, I'm going to go to sleep because I am really jet lagged.